Hi everyone. Now we are going to start lecture 8 of current electricity. The topic is combination of cells. We also done the combination of resistances in series and parallel. Same will be here. If the cells are connected in series, and what is the equivalent EMF or the equivalent internal resistance? So we also have discussed that what is series combination. When the resistors or the cells are connected end to end, it is known as the series combination, right? So in series combination, when cells are connected, the negative terminal of first cell is connected to the positive terminal of the another one and so on. This combination is known as series combination. Negative terminal of first cell connected to the positive terminal of another cell. So this end-to-end connection is known as series combination. In series combination, there are two cells, na? One cell having EMF E1, its internal resistance is R1, and another cell having E2 EMF and its internal resistance will be R2. When they are connected end-to-end, then equivalent EMF of both the cells is equals to E1 plus E2. The equivalent EMF is equals to the sum of the individual EMFs of the cells, and the equivalent internal resistance is equals to the sum of the individual internal resistances. This is how by these formulas you can find the equivalent resistance and the equivalent internal series. It may be parallel. When they are connected end to end means the negative terminal of the first cell is connected with the positive terminal of the another cell and so on. This combination is known as series combination. Right? In series combination, we have to find the equivalent EMF and the equivalent internal resistance. So to find the equivalent EMF is equals to the sum of the individual EMFs of the cells. And to find the equivalent internal resistance, the equivalent resistance is equals to the sum of the individual internal resistances. Right? There is also the condition for maximum current in series. What is that condition? As we know that I is equals to total EMF upon total resistance. The total EMF, if we have n number of identical cells connected in series combination, if we have connected n number of cells connected in series with a battery, then current is equals to total EMF, that is NE, upon total resistance. Total resistance is internal plus n cells internal resistance. There is one external resistance, right? And the sum of n number of internal resistance, that is NE. It is a condition for the identical cells. If we have n number of cells connected in series along with an external resistance, and there are n number of internal resistances, right? So equivalent sum of equivalent internal resistances NR and EMFs NE connected with the battery. So this is the condition I is equals to NE upon R plus NR. This is the formula. And what you have to remember, if the value of external resistance is greater than the net internal resistance, then the cells should be connected in series combination. So these are the formula when the cells are connected in series combination. Next one, the parallel combination. In parallel combination, the positive terminal of all the cells is connected to the positive terminals and negative terminal is connected to the negative. That means all positive terminals are connected with each other of all the cells, and all the negative terminals of all the cells are connected with each other. So positive and negative. So this type of combination is known as parallel combination. So there are two cells having their EMF E1 and E2 and having their internal resistance R1 and R2. They are connected in parallel combination. So what is the formula for equivalent resistance in parallel combination? So equivalent is equal to E1 R2 plus E2 R1 upon R1 plus R2. Hence for R equivalent is equal to R1 R2 plus R1 plus R2. These are the formulas used for E equivalent and R equivalent. Condition for maximum current. In series, there are n number of cells, identical cells connected in series combination. Here are m number of identical cells are connected in parallel combination. So their equivalent EMF is equal to ME and their total resistance is equal to external plus internal, MR plus R. And when the value of external resistance is smaller than the net internal resistance, the cells should be connected in parallel combination. So this is a combination of cells. Next is heating effect of electric current. As we mentioned earlier in the starting of the chapter, that there are three effects of electric current. Number one, heating effect of electric current. Second, magnetic effect of electric current. And third one, chemical effect of electric current. Here we only talk about the heating effect of electric current. As we discussed earlier, when electric current passes through a wire, how electric current flows, we have discussed in the starting of this chapter. When we connect the battery, we provide the potential difference per unit length, due to which it provides a drift velocity to the electrons, due to which they start flowing through the conductor. That means current starts flowing. When the current starts flowing, charge is in motion. It creates both the fields around it, electric field as well as magnetic field, right? And when current starts flowing, there may be many electrons, atoms and ions. Electrons collide frequently, many times, several times with other atoms, electrons and ions. Due to this collision, there is loss of their kinetic energy, which ultimately transform into heat energy according to the law of conservation of energy. We have discussed it earlier, right? So due to the frequent collisions, kinetic energy is converted into heat energy. So that conductor produces heating energy. That effect is known as heating effect of electric current. So what is heating effect of electric current? The phenomena of producing heat energy. The phenomena of producing heat energy through the conductors when electric current is passed through them, right? When electric current is passed through a wire, it becomes heat up. So it produces the heating effect of electric current. Just like you saw bulbs in your home, electric bulbs, electric heaters, toaster machines, they all heated up when electric current passed through them. Why they heated up? Due to the motion of the electrons or the collision of the electrons. The loss of the kinetic energy is converted into the heat energy. So due to this random motion, due to their collision, the wire or the material or the metal or the element gets heated up, and we can use that heating element in various applications, like in electric iron. You press your clothes now, so in electric iron, in electric heaters, immersion rods, toaster machines, all these things use the heating effect of electric current. Electric fuse will be also there. We have discussed in the upcoming topics. So this heating effect of electric current, in which elements or the metal or the conductor gets heated up when electric current passes through it. This is known as heating effect of electric current. The phenomena of producing heating energy through the conductors when electric current is passed through them is known as heating effect of electric current. Is known as heating effect of electric currents, right? So this law of heating energy is given by Joules. This is also known as Joules law of heating. This is also known as Joules law of heating. According to Joules law, Joules law of heat energy, it states that the heat energy produced is directly proportional to the current flowing through the conductor. The heat energy produced through the conductor is directly proportional to the current flowing through the conductor. Second one, heat energy is directly proportional to, H is directly proportional to I square, the square of the current flowing through the conductor, square of the current. H, second one, H is directly proportional to R. Third one, H is directly proportional to the time duration during which the current flows through the conductor. So when we combine these three equations, by combining three equations, first, second and third, what we got? H is directly proportional to I square RT. Directly proportional, when we remove the sign, H is equals to I square RT. This equation is known as the equation of Joules law of heating effect. This is a formula for finding the heat. H is directly proportional to Y square, H is directly proportional to R, and H is directly proportional to the time duration. Suppose if I just switch on the key, during which the current starts flowing through the heater, if I have a heater, and I just suddenly after 1 second or 2 seconds just switch off the circuit, then is that wire gets heated up? And in another case, if the current starts flowing in that heating effect for in that heating electric heater for 1 hour, so in which case from the both cases heat energy produces the more? The second one case, in which the time duration is 1 hour, so that it can produce the heat energy, it takes time to get the heat energy, to produce the heat energy, right? The formula for H is equals to I square RT. H is directly proportional to I square, H is directly proportional to R, H is directly proportional to T. So this is heating effect of electric current, that when electric current is passed through a wire, it becomes heated up. Joules law of heating gives the formula for heat energy or heat dissipation, right? Next, cause of heat energy. How can or why can heat energy produce? So due to the frequent collisions. Due to frequent collisions of electrons with other atoms, electrons, ions, there is loss of their kinetic energy. There is loss of their kinetic energy, which converts into heat energy, right? There is law of conservation of energy. If there is decrease in one energy, that it can transform into the another one. So when due to the collision there is loss of their kinetic energy, it transforms into the heat energy. That is known as the heating effect of electric current when the wire gets heated up or the conductor gets heated up. So we can use this heat energy in various applications, like in electric iron. You press your clothes, na, you iron your clothes. So in heating element, the heat energy is produced. So electric iron, electric toaster machines, immersion rods, electric heaters, all these are based on, even electric bulb, electric fuse. These are the applications of heating effect of electric current. These are the electrical appliances on which in which heat energy is used. Applications, as I told you, number one is household heating appliances. We are doing applications of heating effect of electric current. Number one, household heating appliances like electric bulbs, heaters, electric heaters, immersion rods, toaster machines. These are some appliances which use the heating effect of electric current. Their heating elements get heated up and we can use that heat energy, right? So this is one application of heating effect of electric current. Next one, electric bulbs also use or also based on the heating effect of electric current. When electric current is passed through an electric bulb, it converts the electric current into heat and light energy. What does electric bulbs have? Electric bulbs have nitrogen and argon. These are inert gases which are filled in between them. These are some inert gases. And electric bulb also has tungsten as a filament. Suppose this is the bulb, right? There is tungsten like that. It is like that, something like that. So it is filament. The filament of electric bulb is of which material? It is of tungsten material. Which material is used here? It is tungsten material. And this tungsten material, the melting point is very high. Its melting point is high. Why we keep the melting point? Because electric bulb converts the electric current into heat and light energy. So it converts into heat energy. It gets heated up. So to bear that heat energy, the melting point of the material used in a filament must be high. The melting point is high. Resistance is also high, which produces heat energy. Because we see in the formula of heat energy that H is directly proportional to I. So in case of electrical appliances which use heating effect of electric current, those resistance and resistivity must be high so that they can produce larger amount of heat energy. Like in all these appliances, they have high resistance, they must have high resistance and high resistivity, and they also have high melting point. Their melting point must be high, right? So here also the melting point of tungsten is 3380 degrees Celsius, that much. So tungsten is used as a filament. It is used as filament in the electric bulb to bear that heat energy, because heat energy is produced in the electric bulb and light energy is produced very little. 1 candela light energy for consumption of every watt of electric power. 1 watt की electric power के लिए कितनी light energy produce करता है electric bulb? 1 candela, right? So this is electric bulb which is based on heating effect of electric current. Sometimes the questions may be asked that which gases are filled in the electric bulbs. In many competitive exams, it will be asked that which gas is filled in the electric bulbs. So nitrogen or argon, which are inert gases filled in the electric bulbs. And what we use as a filament in electric bulbs? Tungsten, and whose melting point is very high, approximate 3380 degree Celsius. Next, electric fuse. This may also be asked. Electric fuse is a safety device. It is a safety device which breaks or melts when the current exceeds to a safer limit. Safety device which melts down or break down when electric current exceeds to a certain limit or the safe limit. And it prevents the possible fires or the possible electric short circuits. Right? When the current through a wire, through this electric fuse exceeds to a safer limit, its melting point is low. That's why it melts or the breakdown, and it prevents the further electrical appliances to get damaged or to avoid the possible short circuits. It will be like we said na ki the electric fuse is melt down or broke down. In nowadays we use MCBs, miniature circuit breakers, instead of fuse, but still many appliances or many houses currently have electric fuses. So what are the properties for electric fuse? Their melting point must be low. Okay? They have low melting point and they have high resistance and high resistivity. The resistance and resistivity in case of heating effect of electric current or the appliances which are used or which are based on the heating effect of electric current, the resistance and resistivity must be high because H is directly proportional to R. If they have high resistance, they can produce high amount of heat energy. It depends on application to application whether they need high melting point or low melting point. Like in case of household electrical appliances, we use high melting point. In electric bulb, melting point is also high because they have to bear the heat energy. But here, fuse is just a safety device to prevent the household electrical appliances to get damaged. So here the melting point must be low so that it can easily break when the current exceeds to a safer limit, right? So the melting point of, so electric fuse is a safety device which melts down or break down when the current exceeds to a safer limit. It has low melting point but high resistance and resistivity. H is directly proportional to R. That's why resistance and resistivity must be high, right? We can use alloys. We mostly use alloys instead of the pure metals in heaters or as a heating element. Why not pure metals? Because alloys have high resistance and resistivity instead of the pure metals. Like we use nichrome wire in electric heaters. Why not pure iron? Because nichrome has high resistance and resistivity so that it can produce great amount of heat energy, and we use the heat energy, we need the heat energy in the electrical heaters, na? So that's why. Next application, we can also use the heating effect of electric current in electric welding, hot wires, ammeters and voltmeters. There also we use heating effect of electric current. So these are some devices which use heating effect of electric current. So in today's class, we cover combination of cells and heating effect of electric current. In upcoming classes, we discuss about electric power and electrical energy and Kirchhoff laws. So very small amount of topics will be left. Okay, we ended the lecture here. Thank you.